All right, so here we go with example 2. So this is continuing our work with the limit definition of the derivative, okay? And it says to find the derivative of 5x squared minus x, again, using this limit definition of derivative. And I just want to, this is on the other side of your paper, but just so we have it here as a visual, this is what we're talking about. Limit as h approaches 0 of f of x plus h minus f of x all over h, and we're looking at this as h approaches 0. And we already know going into it that this is going to be an indeterminate limit. This is set up in a way where it has to be indeterminate. Okay? So what I'm going to do is I'm not even going to write it as a limit here to begin with. Or actually, I guess I am. I'm going to take this and figure out what does f of x plus h look like. Well, okay. This is why I was debating this. This is going to take me a minute. F of x plus h means I'm putting x plus h in for x in every place that I see it. So this is now going to say 5 times x plus h squared minus, and then notice I'm putting this in parentheses because if I'm subtracting x, I want to make sure I'm subtracting all of x, and this x plus h is now standing in for x. And then I need to do minus my f of x function. Well, this is f of x, but again, there's two pieces here. So when I say that I'm subtracting that, this is going to need parentheses as well. So 5x squared minus x. So this from here to here is f of x plus h, and this is f of x. And then all of this is over h. And so what I'm doing now is I'm taking the top of that fraction, and I'm going to kind of take it off of there. Well, I'm going to take the whole fraction off of the limit expression, and I'm going to see what simplifying I can do, and then I'll come back up here and start thinking in limits again. Okay, so I'm going to FOIL this thing, and I'm going to write the FOIL out up top here so you can maybe follow it if you weren't following it before. X plus h squared means x plus h times x plus h, right? So x times x is x squared, and then I get an x plus, or an x times h, and another xh, and then on the end I get h times h, which is h squared. Okay, so that's what the FOIL looks like of just x plus h times x plus h. This also has a 5 in front of it. So I'm basically taking these pieces, which remember this would actually give me a 2xh, and I'm going to multiply all of them by 5. So that's going to start with a 5x squared. My 2xh times 5 gives me 10xh. And then I have my h squared times 5, so 5h squared. Minus x plus h. Well, if I'm subtracting x plus h, that's going to translate into a minus x and a minus h. Okay. And then minus 5x squared minus x means I'm going to have a minus 5x squared. And minus negative x means I'm going to have a plus x at the end. Take a second and pause here if you are not sure where those numbers all came from. Take a minute and think back through those steps that I just took, because what I just did is the hardest part of this whole process. So if you do not understand the algebra, maybe back up the video, watch it again, make sure you understand where each and every one of these pieces came from. I do want to remember that all of this is over h, but before I deal with this h hanging out on the bottom, let's see what we can do out on the top. I see 5x squared minus 5x squared. Those are going to go away. And then I see a minus x and a plus x. Those are going to go away. And then I'm going to look at all my h's, right? Because this says that I'm dividing by an h. So if I'm dividing by an h, I need to lose an h here, and I need to lose an h here. And then be careful here. This is a negative h, and if I do h over h, I mean, a lot of us are going to want to just cancel that. But if all that's there is an h, when I divide, this actually becomes a minus 1 when this cancels, right? Because h over h would cancel and leave me with a 1. So if I look at what I have left now, oh, and then I should cross out this h on the bottom is gone now too. What I have left here is a 10x, a 5h, and a minus 1. And everything else is gone. That is what I'm carrying back up here into my limit. So I'm going to say, all right, now let's say that what I'm really doing is finding a limit as h approaches 0 of this expression. So 10x plus 5h minus 1. And that means I'm going to put a 0 in for h. So that's going to give me a 10x. If I put 0 in for h, this guy's gone, right? And then I'm left with just a minus 1. That is my derivative, that 10x minus 1. So I would write this as, let's see, I want to use a different color. If this original was f of x, I would now say f prime of x equals 10x minus 1. That's my notation for a derivative. That's my proper notation for a derivative. Okay? So then the next question wants us to graph the original function and graph what we just found and kind of verify some of that function relationship. And I was going to flip out to Desmos, but my screen wouldn't quite cooperate. So let me get my calculator to play along here. 5x squared minus x is my original function. And then 10x minus 1 is my derivative function. I'm going to graph this, but I want to make sure that my window is set to a standard window. Okay, so there's my 5x squared minus x. Ooh, that doesn't quite look right. Yeah, I guess that's right. I just can't see it very well. Let's take my window down. Okay. What we should be noticing is that I'm still not seeing what I want to see. Let's see. I want to take this down. I'm just trying to make sure we can see the important piece here. Yes. Okay. See my vertex of my parabola right there? It is hard to see because it's just barely under the line. Okay? But you'll notice that this line that comes through crosses the x-axis right at like kind of the lowest point of that parabola. If I were to go find that vertex, that's exactly where my line is crossing. And that's because that's the place where my derivative is equal to 0. Let me take the line out of there for just a second so we can look at just the parabola. So if I go to the very bottom of this parabola and draw a tangent line, it will be a horizontal line, which means my derivative at that point should be equal to 0. Okay. If I turn this back on and take a look at it, we will also notice that the left side of my parabola graph is all decreasing. All of this is decreasing, and that corresponds with negative values on my line. As soon as I cross that vertex point, these are all increasing, and now you'll see positive values here. Okay? And so if I look here in my table, just for example, oh, this is a bad example. Let's see. Make my table start at 0. What this is telling me is that if I look at x equals 0 on the graph, this is telling me what the function value is. Honestly, most of the time we don't care about that. But my derivative at x equals 0 is negative 1. So if I was to draw a tangent line at x equals 0, I would have a slope of negative 1. If I go to where x is equal to 3, my slope would be 29. My slope of my tangent line would be 29, which should actually make sense to you because 3 is like way off this graph. So it's going to be way up here someplace. And then if I draw the tangent line at that point, it would have a very, very steep slope of 29. So when I'm looking at this table, just so we're interpreting this, these are the function values. These are the values that are making the actual parabola. These are the slopes of your tangent lines. Okay, so if you were to go to this x value and draw the tangent line, these are your slopes. And you'll notice these up here are all negative. because again, the left side of the graph is all decreasing, so they all have negative slopes. I also would like you to notice the relationship that we've talked about already. So we learned on the previous page that the derivative of just x squared is equal to 2x. Okay? So when I throw a 5 in there, what ends up happening is that 2x gets multiplied by 5. And so I end up with a 10x. Okay? So that 10x came from the fact that this was 5x squared. The minus 1 came from the fact that I had a minus x floating on here. And that should make sense to you, because if I just talk about the function negative x, okay, just negative x by itself, that is just a line with a slope of negative 1, right? And so if I were to go anywhere on that line and say, hey, what's the slope of the tangent line right there? You're going to tell me it's negative 1, because that's what it is anywhere on that line. If I had the equation y equals 3x, let's say, and I were to ask you for the slope anywhere on that line, I would hope you would tell me it's 3. The derivative of this thing is always 3. And that's where this minus 1 is coming from, is the derivative of the minus x. You don't actually have to know any of that yet. That's just the direction we're heading in. I'm telling you that because I want you to see that you're not doing this forever. Okay? We're going to do this a couple of times to make sure we understand this process, and then we're going to start to learn all sorts of tricks and rules like that one I just showed you about the, hey, you can just take 2x and multiply it by 5. That's where we're eventually heading with this. So you do not have to stress about doing this long term, but you do have to understand that this is what the rules are based on. Okay, is where that's coming from. Okay, speaking of things that you will and will not have to do long term, this example 3 is probably the most likely way that this concept is going to show up on the AP exam. I'm going to just jot for you here real quick, and actually maybe I won't make you watch me write it. Okay, there you go. Those are our 2 limit definitions from the other side of the page. This is what you're actually going to have to be able to do with these. You should be able to recognize them when you see them. So when I look at this expression, I see it's a limit as h approaches 0. I'm seeing that telltale like x plus h in here. And what I want you to look at and say, what I want you to be able to do is look at this and say, oh, that's asking me for a derivative because I recognize that derivative definition. So the function that we're talking about here is, and the easiest way to spot this is f of x is kind of hanging out here at the end, so it's right here. The function that they're talking about here is 3x squared, and the question they're asking you is, what is the derivative of this function? Okay? Now, eventually you're going to be able to answer that question. Actually, that one, based on what we talked about up here, you should be able to answer right now. But right now, I just want you to look at that thing and say, hey, that's asking me for a derivative of 3x squared. Okay? One day, that's going to be a really easy question for you to answer, as long as you can recognize that that's what it's asking. Now, this next one, we haven't talked about this at all. I would certainly not ask you to simplify this one by hand, because it's going to take some trig identities that you might not even know about. Some of those like equivalent expressions from trigonometry and all those identities that we learned last year. That's what this guy was going to take. But you should be able to look at it again and say, hey, this looks like this thing. The question is, what is the f of x? What function are they talking about? Well, the function would be tangent of x, right? And because it's a limit as h approaches 0, and this is a slope setup, the question I'm really asking you here, again, is what is the derivative? Okay? Okay, this third one's a little trickier because it's not in that same setup. This is actually one of these, right? This is when x is approaching a specific number. So this has us approaching 5, which means our c value is equal to 5. I might even make a note of that. C value is equal to 5 here. My f of x this time is here at the beginning of my function, so this is where I'm going to find my f of x. So my f of x is equal to 2 to the power of x. And this question is asking me for a derivative, but it's specifically, it's not just the derivative of f of x, it's the derivative at this c value. Okay. So the question this one is asking is, what's the derivative of this function at x equals 5? And again, you don't know how to answer that right now, but one day you will. One day it'll be an easy question, and the hardest part will be, do I recognize what this is really asking me? Okay, this fourth one I think looks a little bit different than some of the others that you've seen. You should still recognize that it looks kind of like this guy, right? We've got h approaching 0. I'm seeing a plus h in here. But the weird thing that has happened is that instead of an x, I have a 3, right? And here I also have like a number where I'm supposed to have my f of x, okay? And what's happening here, similar to this one, except it's in this first form, is this is asking you very specifically for a derivative at a number. It's asking you for the derivative at 3, okay? And that's why we have the 3 plugged in here, and really we have the 3 plugged in here. You just might not recognize that yet. So the question now is, what function is this talking about? What is my original function here? Well, if I took this 3 and replaced it with an x, right, then I would have x plus h squared. So my f of x must have just been x squared, because then I replaced it with an x plus h. And that should make sense here too, because this is really 3 squared, right? If my x value is 3, this 9 comes from the fact that 3 squared is equal to 9. So again, this is f of x is x squared, and it's asking me what is f prime of 3. By the way, we've proven a couple of times that the derivative of x squared is 2x. We did that on the page before, and that's one we're going to use a lot. And so the derivative at 3 would just be 2 times 3, which is equal to 6. And notice I answered that question without doing any of that crazy limit analysis stuff that we did on the other page. So that is the goal. That is what we are moving towards. You don't know enough derivative information yet to be able to do all of these, but you should be able to recognize what the question is trying to get at. Okay, I think that's it for me today. This is a tricky lesson, so spend some time with it. We will definitely talk about it in class some more if you feel like you need some more guidance. But again, don't assume that you're going to live here. This stuff is not going to last for long. Eventually you're going to learn a much more efficient way of doing these problems. So hang tight, practice your algebra, and I'll see you soon.